Okay, we're in section 29 of the notes. The material that's covered in this section, I'm not going to say everything, but it does depend on a lot of stuff that was done in Math 120, and that's the plotting of polar equations, all right, polar relationships. So what I want to do is go to Sage, just a little bit of review about using a computer algebra system. And, certainly I want to, read the code to you. But we're hoping that you're starting to catch on to this and saying that you want to start to get ready for moving towards a four-year institution where Sage, I should say Sage, but a computer algebra system will be used. My big issue with other institutions, a lot of times they're run like military. They say, oh, you have to use this or that, and I'm thinking to myself as you really should start to believe that you should start to use software that you like to use, not because someone says, oh, you must use that. Now, when you work in a corporation, though, you must use the software they're giving you. All right. Now, a few places, I'll be honest with you, at Essex, that's one place that's kind of liberal. They allow me to use whatever I find to be appropriate, which is great. I'm glad it's not like run like a military camp. But anyway, what I do, I reset, I define a variable. Now, this is a multiple letter variable. It's called theta. What is theta? Well, theta is theta. It's a Greek letter, but I didn't know the Greek letter, so I typed in theta, Theta. And then I say R is a function of theta, which will look somewhat familiar to you. And what is it? It's equal to, let's see, sine of 3 star theta. I'll put that there. 3 star theta. Put that in. I got that over here. The next thing is integrate. All right, integrate. All right, I'll put that down. I'm going to copy that. Let me see if I can copy that for you. It says integrate 1/2, let's see, r theta squared theta from 0 to pi over 3. And it gives me an answer over here. Again, I'm going to scroll back over the notes momentarily, but the bottom line is, we're just going through some basic entering lines of Sage, but it's almost mindless. I mean, to do it, to say, oh, gee, this is getting me somewhere. It's not getting anywhere unless you can apply what you've learned. What's df? Df's a new function. R is a function of theta. It's twice cosine theta. And df's a function of theta. And what is it? They want the derivative of r theta. Now that's defined now as 2 cosine theta. And they want to differentiate with respect to theta. And, certainly you can display that if you want. All right, let me do is over here. And again, this is like just copy paste. I mean, I'm not learning anything by copy pasting. How do you learn? Well, you look at it, you read it, and then you try to apply it. So what I'd like to do is go back over the notes. I know this is a problem for a lot of students, by the way. And what I'd like to do is I'd like to see if I could plug this stuff in. I want to see if I can do this problem over here. By the way, what I mean by this is I'm not really reading the problem to you. What am I doing? I'm looking at the code that I just did and see how it relates to the work I did in this blue area. So I'm gonna define a new function. I'm gonna say R is a function of theta. I'm trying to learn is equal to, well, let me write this in. 1 divided by 2 star 12 star sine theta plus 12 times cosine. And by the way, if I make an error, I have a blue area to know I made an error. Theta squared. No error there. I typed it in. Now, what do I want to do? Well, I want to do the integration. So I'm going to type in integrate. I'm going to use tab completion, by the way. A lot of stuff comes up. Do it again. More comes up. I'm starting to see it now. Integrate. What do I integrate? I want to integrate r theta that I just defined, right? Again, we're trying to learn from what we just did. And I want to do this from, across the thetas. Let me put this over here, theta. And what does theta go between? Well, 3 star pi divide by 4 up to pi. Whoops, up to pi. Granted, maybe you can't do it. I don't know. I haven't tried it yet. I'm just trying to learn. And what does it give me? 18 pi minus 36. Lo and behold, what I get over here, 18 pi minus 36. What's the problem a lot of students have? Seeing the relationship between SAGE and the problems that we're giving you over here. Now, granted, you could scroll back over the notes, by the way, and say, you know, I really need to practice SAGE. I need to practice. All right. You know, certainly it's not easy, though. I want to point that out, it's not easy. I just want to go to one of the pieces of software, by the way. And the piece of software I want to go to is Grapher. Because I always say to myself, you know, having more than one tool in your tool chest is a good idea. All right, so let me go to Grapher. And I'm going to put that down for you. I'm going to get the Grapher. And I'll open it up. And I like Grapher because I find it easy to use, but you know, I'll type this in, R squared. Again, when I say it's easy to use, you might find this just the opposite. That's why I say choice is good. Cosine, whoops, I'm sorry about that. Cosine of twice theta. Now, what's nice about this, you know, theta, I know where it is on my keyboard. Whoops, that's not it. That's not it. I don't know where it is. So I'm going to go over here and I'm going to look for it. Oh, it's right there. You see that? All right. Nice. Let's put this down. And what do you get? You get the figure eight. Let's go for this. See if it is over here. And I'm going to look at it. And I do see the figure eight. All right. Let me zoom out. Go back over here. And again, I'm just looking at a different piece of software over here. So it says find the area of one loop of this object over here. Well, I graphed it out. They do give me a picture of it. I was able to reproduce that over there. And so what I want to do is I'm going to take this thing and I'm going to integrate it between 0 and pi over 4. Whoops, sorry about that. You know what? I don't think I can integrate this guy over here because it's not going to let me do it because it's r squared. All right. I'm going to type it a little differently. Square root. Whoops, let me get rid of that thing over here. And again, I realize that's tough. Square root. Whoops. You know what? People may wonder why I just typed in that backslash. I'm so used to typesetting, and in typesetting, that's what you do. Let me see if I can integrate this guy over here. And I don't know if I can. Let me try. Yeah, let's do it. And let me go between 0 and pi over 4. Get 9. And if I double that, I'd get 18, right? All right. Calculate. Let me get rid of this thing over here. Now, I want to point out, I hope you realize that this is a picture. Let me just pull it over. Now, that's certainly not one loop. It's half the loop. And remember, we got 18, right? When I did half that loop. I got a visual of it now. I can see this now. And that's really nice. I can actually see what the area is. It said the area is 18. And what's the, I'm sorry, yeah, the area is 18. I'm sorry. Let me go back because I said something that may not have been true. Let me go back to integration. Oh, I'm sorry. I just did something crazy. Cancel. They're doing something, another computation there, and I apologize for that. And I don't want to do what they just are doing over here. I really screwed up, didn't I? And let me just do this over here. This happens to me sometimes. Oops. Okay. Let me do the integration again. I think I lost it completely. I think I said pi over 4, right? 9. I'm sorry, it is 9. And double that. Let me just show you what I mean by that. If you double that area, you get 18. And I apologize for that confusion. By the way, when I'm using software, sometimes I'm not that familiar sometimes, and I type the wrong thing in, and that's what happened. But anyway, this area turned out to be 9. One full loop would be 18, to double that. All right. Now, granted, I would need to know what I'm doing by hand before I could ever use a machine, right? You notice I had to update the machine to be able to do that graph, by the way. But anyway, we're done. Okay. So I would say pay attention to that. Again, you may say to yourself, I want to use different software. I encourage it. You should also, if you're using different software, please share what you know with other people, right? Start to develop a learning community. Advocate what you find are good tools. Like, what am I advocating? I'm advocating Sage. I'm advocating Grapher. I'm advocating Wolfram Alpha. I'm advocating Mathematica. You may say to yourself, I have something that I like better. Be an advocate. Tell people what you like. By the way, everyone has an opinion, and certainly I'm not going to say your opinion may be shared by everyone. All right. Thank you for paying attention, though.